Hi everyone, this is Cody with OmniMedic Solutions. Thanks so much for checking out our video. Today we're doing a demo video and taking a look at OmniFire. Now OmniFire is our friction loss calculator that we have for all the firemen in the audience. It was the spin-off of our drip rate calculator OmniMedics that's available on the iTunes App Store and on the Google Marketplace and on the Amazon Marketplace for your iOS and your Android powered devices. Now I'm a full-time fireman. I was a fireman way before I was a medic, and that's where my roots are, and that's where I developed this app when I realized that I could kind of take some of the formulas that I use for OmniMedics and tweak them a little bit and use the same concept to come up with a friction loss calculator, because let's face it, in general, firemen generally aren't that great at math. So doing the math really isn't the hard part. Anybody can punch numbers on a calculator to come up with an answer. The hardest part usually is remembering the formulas and the coefficients that go along with doing a friction loss calculation. The good thing is that OmniFire keeps track of that for you. All you have to do is punch in the variables, which are your hose line diameter, the length of your hose, your flow rate, all that stuff, and then OmniFire will run the calculation for you. OmniFire uses the standard formulas that we were all taught. Friction loss equals CQ squared L, and flow rate GPM is 29.7 D squared times the square root of nozzle pressure. So that much is pretty much standard no matter where you go. It just takes and incorporates all of these things into one place. Now, a lot of people will say any pump operator who needs an app to figure friction loss isn't worth a crap. I'll agree, you need to be able to figure out your friction loss quickly on the fire ground using something like the hand method or the rule of thumb. You know, the rule of thumb where the guy at the end of the line gives you a thumbs up for give me more pressure, gives you a thumbs down for less pressure. Yeah, you need to be able to calculate quickly on the ground, but here's where OmniFire comes in, where it's kind of cool. OmniFire allows you to quickly pre-calculate your friction loss for a given line. So if you're sitting around the station, you're kicking around numbers, and you want to know, okay, what friction, what flow rate am I going to get out of my number one pre-connect, and what GPM and what friction loss, what pump pressure do I need to pump it at? You can figure it pretty quickly with OmniFire. The second thing that it does is, if you're teaching new pump operators the pump ops class and how to do all of the formulas, OmniFire will check your math for you to make sure that you get the right number as your students who are learning to calculate things by hand. And three, and this is kind of what I think is the biggest one, if you're kicking around the idea of changing a layout, now I know we don't change things very often in the fire service, but sometimes we have to, of changing the layout on your truck. So for example, let's say that you've got a 150-foot 1 3/4 pre-connect, and you're looking at changing it to a 200-foot 2-inch pre-connect. One of the things that you're going to have to do is figure up what kind of pressure difference you're going to have to be able to pump to go to that, as well as you can look at it and figure out how many more GPMs you can get out of that line as a part of your decision-making process. So OmniFire can quickly do that math for you to see what kind of friction loss you're looking at, what kind of GPMs you're looking at, and all that kind of stuff, instead of having to calculate things out the long way. The other big thing that OmniFire will do, and I actually didn't come up with this, one of the guys that's a driver at my station came up with this after I came out with this app and gave it to him, is OmniFire will allow you to do a back calculation to experiment with theoretical flow rates. If you're not familiar with a back calculation, it's just what it sounds like. It's where you start at an ending point, we'll say some desired flow rate, and then you work backwards to see what the required pump discharge pressure is to get that flow rate. By doing that, that allows you to determine if that flow rate is even possible. So we're going to take a look at the features, and we're going to run a demo. So whenever you open it up, this is what you get. One of the things that you'll notice with all of my apps is they're extremely simple. I don't like lots of frills and lots of bells and whistles, because let's face it, if I'm going to use one of these apps at crunch time, I don't have time to jump through a bunch of hoops and dig through a bunch of menus to figure out what I need. So all you see is this is your main screen. We tell it new line, that's pretty self-explanatory, and then here's what you get. So let's say that we're going to do a new line. We're going to run a hand line, so you can see that hand line is selected. So at my department, we use low pressure nozzles, so we're going to use a 75 PSI fog nozzle. We're going to run it with an 1 3/4 line. We're going to tell it that we're going to do 200 feet, and I'm going to set my nozzle at 125 GPMs. Now, you can also see that you have a place for appliance loss and you have a place for elevation loss if you're going up a flight of stairs or going into a second or third story. We're not going to use that for this demo, so we're going to tell it to calculate, and it's going to tell you all of your information for this line. Your nozzle pressure is 75, your friction loss for that setup is 48, so your pump discharge pressure needs to be 123 psi. Okay, that's pretty simple, right? So we're going to tell it to add the line. So the next thing is, okay, we've decided that that line's just not cutting it. We've got a big fire, so we need some big water. So we're going to add a new line to our setup. So this time we'll say that we're going to do a 2.5 inch play pipe smooth bore. So on a smooth bore nozzle, we're going to do our 50 psi for our smooth bore. We're going to use a 2.5 inch big hose. We're going to have a 250 foot run this time. Now then, we have to figure out what our flow rate is for that particular nozzle. So where it comes in, you don't know exactly what that is probably. So if you tap on your question mark, it will give you the option of this screen to figure up your GPMs. So we'll say that we're going to unscrew all the way down to the 1/8" tip for this play pipe. We're using 50 psi for our discharge pressure. We're going to calculate it, and it tells us that we're going to flow that setup is going to flow 266 GPMs. Now then, you'll notice that you've got anywhere from a 1/2 inch all the way up to 3 1/4 inch. So you can figure out huge water flows, master streams, all that stuff by using this GPM calculator. So we've already got it calculated. We're going to add it to the line, and if you notice, it automatically puts in that's exactly 266 GPMs. So we're going to tell it to calculate this time, and it tells us that the friction loss in this setup is 35 psi. Add that to your existing nozzle pressure of 50, so we're going to need to run this line. We're going to gate it back a little bit. We only need 85 psi to get 266 GPMs out of it. So we're going to add this line. Okay, so now let's say we want to do a supply line, and there's two different ways that you can calculate supply lines with OmniFire. We're going to tell it to add a new line. The first way that you can do it is by selecting the supply line feature, and if you notice, you can toggle it on and off. If you notice, it takes the nozzle pressure out of the equation because obviously we don't have a nozzle on the end of a supply line. So let's say we're going to lay 5 inch and we're going to go 800 feet. It's going to be an 800 foot run, and we're going to flow 1250 GPMs. So when we calculate it, it tells you that you're going to have to pump at 125 psi to get that flow rate 800 feet downstream. So we're going to add this to it so that we can see the features. So now then, here's the other way to calculate a supply line. We're going to add a new line. This time, instead of selecting supply line, we're going to leave it on hand line. So let's say that you're supplying a ladder truck. You're supplying a ladder pipe, and the driver on that ladder truck wants 50 psi at the tailboard. Or you're supplying a sprinkler system and you want your policies for your department say that you need 50 psi at the wall. Put that in as your nozzle pressure, 50 psi at the wall. We'll say that we're still doing a 5 inch hose because we're supplying big water to a ladder truck. We're going to do a 300 foot run, and we're flowing 1250 GPMs. So whenever you calculate this time, it tells you, okay, so you've got your nozzle pressure, so to speak, which is how much you want at the tailboard, is 50 psi. Your friction loss for this setup is 62 psi. So you've got to pump it at 112 psi to make sure that you get 50 psi at the tailboard for that ladder truck. So I mentioned something earlier about back calculating. So what's up with that? So we're going to add this to our setup, and we're going to add a new line for a back calculation. So back calculating, you start with an endpoint and you work backwards to answer a question. For example, we'll say that the question that we want to answer is, what's the maximum flow rate through 5 inch at 800 feet? So if say that we're going to do a supply line, so you've got 5 inch and you're running 800 feet. So let's just take a shot from the hip and say, okay, can I get 2500 GPMs out of 5 inch at 800 feet? So when you tell it to calculate, it tells you that your PSI, your friction loss, is 425 PSI. So in other words, in order to get 2500 GPMs out of 5 inch, 800 feet down the run, you've got to pump it at 425 PSI. So what that tells you is that number is way too high, and that output isn't possible for that distance. So you either have to cut your GPMs down, or you have to cut down the length of your run, or lay a second line or something like that. So we know that that's not possible. Okay, so let's say that we want to back up and go, okay, well, what if we back it down to 2,000 GPMs? We take a look at it and it tells us that your friction loss is 281 psi. It's a little closer, that's a little better, but I still don't particularly like it that much. So let's say that we want to do, let's back it down even more to 1,500 psi. So this tells you to get 1,500 GPMs out of 5" at 800 feet, you've got to pump it at 169 psi. That's a little bit more reasonable, so that's something that's doable. So we'll say that for our purposes, if my policies say that we can't exceed 175 psi at the panel, that would be the maximum amount of water that we can get out of 5" at 800 feet. The bottom line is you can run all of these friction loss calculations without ever having to pick up a pen and a piece of paper. Now then, it will not work with CAFs, and the reason it won't work with CAFs is because that changes the entire dynamic. If you're not familiar with CAFs, that's something that's sweeping the country right now. It's compressed air foam system. If you ever get a chance to use it or demo it, it works phenomenally. So please give it a try and give it a thought. That's another whole argument in itself. Anyway, OmniFire won't work with CAFs lines because that changes the whole thing, because you're flowing air and water and you have a reduced flow rate. I'm working on trying to figure out how to incorporate a formula for CAFs into OmniFire. Until then, sorry, can't work with you on that, but it will work for all of your water lines. So one more feature that I want to show you to make sure you're aware of, just like in anything else with the iOS features, you can swipe and delete any particular line. You can also go in and edit a line and say, okay, we need to throw another stick of hose in here and make this a 300-foot run, and it will calculate it, and you can edit it and go back to the line and it will redo all of the calculation for you. Now then, to go back into this one, remember I told you about the appliance loss and the elevation loss. We didn't use it for these demos. All you have to do is add in whatever particular number you would like or your department says for appliance loss. So let's say if your department says anything over 300 GPMs gets a 25 psi appliance loss, you can add that in and it adds it as a line item. We'll also say that if your elevation is 15 feet, now remember this is feet, not stories, not half PSIs, it will add in 1/2 psi per foot, so your elevation loss for this is 3 psi. And then it lays all of these things out for you so you can see exactly what they are. So that's all there is to it. This is OmniFire. It is currently available on the iTunes App Store for your iPhone, your iPad, and your iPod Touch. Please be sure to share it with the guys at the firehouse. Again, I'm a fireman just like all of you guys are. Developing these apps is my side job. I always welcome input from anybody that takes and uses the apps, so please, by all means, check out our webpage, OmniMedicSolutions.com. If you have a suggestion, please drop me a line. Again, keep in mind, I'm on shift every third day like a lot of you guys are, so I do this on the side, so I may not be able to get back to you right away, but I do read all of your emails, and I will take into consideration any suggestions that you guys have for future revisions. Also, while you're at it, be sure to check out our Facebook page. That's facebook.com/OmniMedicSolutions. Again, feel free to contact me over there if you'd like, and for any feedback. Thanks so much for watching the video. I know it got a little bit long, but thanks for sticking with me to the end, and be sure to check it out. For those of you who are Android users, we are working on an Android version. Please be patient as we work on it. I'm working on it with my programmer right now, so hopefully we should have that out within the next few months. Again, thanks so much. You guys be safe out there.